Hey everyone, Mr. Fritz here. In this video, we're going to talk about 2D vector operations. We're going to add them, we're going to subtract them, we're going to do a little bit of scalar multiplication. So let's jump into vector operations. And before we even go any further, just watch. I want to have a little bit of a thought experiment, or at least just think about a problem before we get into the nitty-gritty details. So consider this. We've been actually talking about vectors without realizing it. Bearing problems are an example of this. These vectors are called displacements. So a typical problem could be a runner runs in an easterly direction for 4 kilometers and then in a southerly direction for 2 kilometers. This can be expressed with a triangle, east running for 4 kilometers, south running for 2 kilometers. And if the question became what is the total distance, or how far did this runner go from the starting point and in what direction, this is a bearing problem. And you can use a right triangle to create or to figure out what that hypotenuse is, and that would be your total distance run. And then you can use a little bit of trig to find what that last angle is. So we would have to use the Pythagorean theorem to find what this distance is. We'd have to use some inverse trig to find what this angle is. And that really is vector addition without even calling it that. Again, imagine, here's just another thought experiment or example to think about vectors. We have this thing called resultant vectors. We're going to talk about that through this video. And let's think about if I were to start at my house and I want to go to the Grand Canyon and we're flying or driving, you can get there a number of different ways. Let's say that I start my trip with a flight to Chicago, and then I take a flight from Chicago to the Grand Canyon. That's one way I can get there. Or let's say I want to take a little bit of a southerly route, and let's fly to Texas first. Let's go to Austin. I can fly to Austin, and then I could fly to the Grand Canyon from there. Now, no matter what my flight pattern, I could even go into Canada, and then I can come back down to the US, and then I can even overshoot it. And let's go to Seattle, and then I want to come back down to the Grand Canyon. No matter how you slice it, at the end of the day, you are beginning at one place, and you are ending at another. So all of these paths, they all begin in the same spot and then they all end in the same spot. And what we'd call this like beginning and ending vector, we'll call it, would be like the resultant vector. So keep that in mind as we think about what the overall motion is from beginning to end over a course of a trip. So let's talk about vector addition. To begin, if we want to add two vectors, A and B, we're going to first think about drawing this vector. So just like we talked about in the last video, we can represent vectors geometrically. And here are two vectors, vectors A and vector B. So if I wanted to add A plus B, the first thing I'm going to do is I'm going to draw vector A. And vector A looks something like this. That's about right. That's my vector A. Let's go blue here. That's my first step, to draw the vector. And then I want to, at the arrowhead of the end of A, vector A, I want to draw vector B. So here is my vector A. It begins here and it emanates to this terminal point here. At the end of this vector, or at the tip of this vector, I'm going to start my vector B. So let's draw vector B, and that's a vertical vector, and it's about this long. And this would be vector B. So there I've drawn from A, my A vector, to my B vector. I've connected we say tip to tail. And my final step would be to join the beginning of A to the arrowhead at the end of B. So that's going to look like this. That's going to look like from the beginning of A to the end of vector B. What I've just drawn here is called the resultant, or is also known as the sum of vectors A plus vector B. So the sum of these two vectors is called the resultant. And really the resultant is considered to be from the first starting point of a vector, of all your vectors, from the first starting point to the final endpoint. In this example, I added 2 vectors, but I could have added 3 or 4 or 5 or 6. Really, the resultant at the very end is your beginning first point all the way to your ending final point, and that's called the resultant vector. So that's how we add vectors. So let's see another example here. I have 2 vectors A and B, and we're going to get a little bit more precise with these diagrams by using actual grids. And we want to add vector A to vector B. So what I'm going to do first is I'm going to draw my vector A. And the way that I kind of think about this is I think about, it's almost like a slope, how many I'm going over and how many I'm going up. So vector A looks like it's going to, I'll begin here. I'm going to go over to the right 3, and I'm going to go up 1, 2, 3, 4. 1, 2, 3, 4. This is my vector A. And I want to add to that vector B. And vector B looks like I'm going to go down 2 and to the right 1, 2, 3, 4. So I'm going to go down 2 and to the right 1, 2, 3, 4. That will be my vector B. The resultant, or the sum of these 2 vectors, is what I get when I connect the beginning of A to the end of B. So that looks something like this. And that is my resultant vector. And we'll call that vector A plus B, vector B. So this is my resultant of adding those 2 vectors together. So pretty straightforward. Again, take a look at how far you go over in the x and how far you go over in the y direction. And as long as you draw your, we call it tip to tail vectors, the resultant is from the beginning to the end of my string of vectors. So in this next UTry, oh, there's the answer there. You're going to have a UTry example. Why don't you give that problem a try, and then resume the video when you're ready to see the answer. So here's the answer to the UTry number 1 problem. Here's P and Q. I drew those 2 vectors and the resultant vector, which is the sum vector P plus vector Q. There's another UTry. Why don't you give this next one a shot? Same type of idea. Remember, you can move these vectors around and we're still adding together P and Q. So give this problem a shot. All right, so here is what my solution looks like. Vector P plus vector Q is this resultant here from the beginning to the very end.